Good morning everyone, my name is Stefano Scanzio, and in this 10 minutes video I will show you some theses about my research activity and the theses are at Politecnico di Torino. Before starting about the main topics, I want to show you some points related to the thesis. So first of all, typically I select a maximum number of students that are 3, 4, 5 students maximum a year, because I think that one of the main points of a thesis that the thesis need to be followed at least 2 or 3 times a week. Another important point is that I typically want students with a good average. There is not a rule, but typically, for instance, 25, 26, 27 of average is a good point, but in any case it is not a rule, in the sense that depends also if the thesis likes the specific arguments of the thesis. Then typically all the theses I provide to you are scientific theses and typically they will provide at the end a publication. So if you see my website, you can see that at the end the majority of the thesis led to a scientific publication that typically is not done exactly during the thesis, but is done 6 or 1 year later, because we need sometimes in order to publish the article. For the thesis you can do at home or inside our laboratory. You can decide, you can choose. The thesis can be performed in Turin or in Milan. Again, you can choose, because I spend some of the time of my time in Milan, where I live, and some of my time in Turin. In Milan is in Politecnico di Milano. Typically, another important point is to limit the duration of the thesis. So it is important to stay from a minimum of 6 months, that is the minimum, to 8-9 months, but not more, because I think it is important that you spend correctly the time you have in order to finalize the works of the thesis in a bounded time. Regarding the arguments, I will express in this video 2 main arguments. The first one about industrial networks, that is my main research activity, and in particular related to industrial networks, I will show you a research activity about the use of machine learning techniques in order to assess channel quality. Then another important research activity is about wide sensor network, and in particular a protocol that is named TSCH. In this context, the target is to save power, so to have a protocol, a network with low power consumption. Finally, related to industrial networks, there is an activity related to Wi-Fi, so to the use of the Wi-Fi protocol in industrial networks in order, for instance, to pilot robots. In this case, the idea is to have low latency. I know that you are a course more on software, but the strange thing is that when we speak about such a kind of networks, at the end the software part is the main part, because, and the other important point is that research in industrial networks involve basically all the things you learn in the university, so from machine learning to the programming part to the more physical part related to networks. And then we have another activity about eQR codes that for me is more an hobby. This activity is more related to the course of formal language and compilers, and I will show you that the idea is to place inside a QR code an executable. We are the only group that do this, and is also this one a really interesting activity. So I will analyze this activity one by one, starting from the first one related to machine learning. And in particular, in this activity, we use a setup that is composed by an access point and by a wireless station in order to acquire a database. So basically, we send cyclically a data from the access point to the station reply to the sorry, I do the opposite way. So we have the star and the access point. Starting from the star, we send cyclically a data to the access point. The access point, if receives correctly the data, reply with an ACK frame, and we collect some statistics. In particular, we collect the fact that the data was correctly delivered, so a 0 or a 1 that represent not arrival of the packet, or better of the ACK frame, and arrival of the packet. Then we collect the starting time of this sending pattern and then the end time, and in particular we collect the difference between the arrival time and the sending time, and then other statistics, for instance the RSSI of the frame. We collect a really big database. Basically we have 1 year, something less than 1 year, but more or less 1 year of database, and inside this database we train some neural networks or other machine learning algorithms. So basically using the data at time t-1, t-2, t-3 and so on inside this database, we need to in some way to predict the data at time t0. In this feature we can have directly the feature we want to predict or other feature, but in any case we train a machine learning model that, given the past, predict the prevision of this target, and the idea is that we want to minimize the difference between the target and the prediction of the machine learning algorithm. Normal difference, absolute difference, or the square of the difference. We have really a lot of interesting techniques. I have not the time to go in details, but in this part is important the machine learning algorithm, probability, and so on. For this thesis we use the Python programming language and the TensorFlow framework. If you see the comment of this video, you have two references, reference 1 and reference 2, that are two examples of articles that we done with machine learning. In particular, this one is the result of a thesis with Alberto, that was one of my thesis students. The second activity is related to wireless sensor network and TSCH. In particular, TSCH is interesting because it has the ability to divide the time. So here you have the time, to divide the time into slots of fixed dimension, typically 20 milliseconds or 10 milliseconds. So I have the possibility to have a scheduling. In particular, if I have a network composed by some nodes A, B, C, I can say that in this specific slot there is the reservation that allow to send a frame from node B to node A. So this means that in this point there is a transmission opportunity between node B and node A. So if our node B has a frame inside this buffer, a frame that is addressed to node A. When arrives this transmission opportunity, node B sends the frame inside this slot of dimension 20 milliseconds to node A, and node A is open for reception and receives the frame. This schedule, because I can have, for instance, the schedule from node C and node A and so on, the schedule repeats over time, and in particular in TSCH repeats every 2 seconds. The important points, if we analyze node B and node A, is that in the case there is no scheduling transmissions, node B and node A can go into a deep sleep state and it does not consume energy. This allows to have this node battery powered and to change the battery every 5, 6, 10 years depending on the usage of the networks. Okay, if we analyze real application, for instance telemetry, analysis of temperature and so on, the sending rate, for instance, from node B to node A is 10 minutes, but you see that this transmission opportunity is repeated every 2 seconds, so this means that the majority of this cell are not used. So if there is the transmission opportunity, the node B has no frame to transmit, node A open is listening the channel, and it results in another listening. This means that node A listens the channel, but no transmission takes place. The important point is that the power used to receive a real frame is about 2 times the power of idle listening. And so this means that we spend really a lot of energy in idle listening. So we analyze a lot of techniques, some probabilistic, some less complex. And the idea is to experiment. We have really many techniques to experiment new techniques to increase the lifetime of these networks. In this case, we use Python. We use in particular a framework that is named PySim. So we have our simulator in Python, and the thesis is to modify the simulator in order to analyze and to propose to the scientific community new algorithms. Also in this case you can download and analyze article 3 and 4 that are our article that explain these algorithms. In particular, article 4 was done after a thesis with a thesis students. Related to Wi-Fi, so Wi-Fi is interesting because allow you to connect industrial network without cables, but remember that industrial network has bigger requirements in terms of latency. For instance, the red button that you can push in order to block a factory, a machinery of a factory, needs to have a continuous collection of data with the order of 20 milliseconds. This means that if the PLC that manage the industry for more than 20 milliseconds cannot contact the button that can be used to stop your machinery, you have a block of the machinery. And so the idea is that we need to have Wi-Fi network that are really deterministic, but you know that a wireless channel is a channel shared among a lot of nodes, so we have a big research activity to try to reduce latency. In the case of Wi-Fi, we have two theses. One that is a simulative thesis that use a really important and known discrete event simulator, which is named NS3, so you have a lot of documentation. And so in this case we want to model a situation like this one. We have a switch we have a digital twin. A digital twin is a software that collects all the data from the network and is a digital replica of the network we want to analyze. To this which we have, for instance, connected two access points. So the one I show you is one of the possible scenario we are interested in. Okay, we have two access point, we have some wireless station, for instance cell phone, or in the case of industry, automatic guided vehicles, that are vehicles that goes inside the company. This station send cyclically or not cyclically, in any case send their data to the digital twin. The digital twin perform a model, and knowing the position of the station, the digital twin knows that this station goes to another access point with a better signal than the previous one. So after before the disconnection, the digital twin send a message to the station, say that it has to switch from access point 1 to access point 2. So the station performs the switch to access point 2, and in this way, if I can precede the switching time from one access point to another access point, I have a better connection and I have not a disconnection. That is the things that typically occur if you go with your cell phone from an access point to another access point. So you have a gap on which you have no communication. In the new standard of Wi-Fi, in Wi-Fi 7, there is the addition of MLO, that are multi-link operation. In this case, the future STY or future cell phone will have three antennas, one working at the 2.4 GHz, one at 5 GHz, and one of 6 GHz, and you have the ability to have at the same time this antenna connected to the same or two different access points. So in this case, we can migrate the antennas one after the other, and so we can, when for instance we move this antenna, the other two antenna remains connected, and so we have not we reduce a lot the possibility of having not connection with the digital twin and with the PC that communicate, that manage your industrial networks. So in this case, the work is in Python, but also in C++, so almost in C++, because NS3 is a discrete event simulator written in C++. And also in this case, I can provide, you can find in the description of the video a link to an article that describes this activity. Remember that we are not, I'm an informatic, so all the activity related to the networks are from the Mac layer on, so are not related to the physical layer, but are activity related to the programming part, so are activity related to computer science and not to network connectivity or propagation of signal. Regarding Wi-Fi, we have a second activity that is based on a real setup. In particular, we modify in a Linux system, we modify a little bit a driver in order to obtain some statistics and to pilot, to manage this driver from a user space application. So the idea is that we want to move the implementation of some feature of Wi-Fi from kernel space to user space in order to implement some techniques or to do something else. So in particular, we start with a driver of Atheros wireless adapter, we modify it, we build a first user space application, and we want to implement in this application some techniques, for instance, techniques about redundancy, on which we have two drivers, two wireless adapters, on which we can send the same packet on the two interfaces in order to improve reliability, so to decrease latency and so on. Okay, so in this case we will use this software in order to collect data, so to collect database for the machine learning operation, to analyze the channel from a statistical point of view, or to perform some prototypes, for instance related to MLO, so to analyze a situation like this one, not in the simulator but inside the real device, or as I say, to redundancy. So this activity, I think, is also a really good activity, but in this case it's better for students that like operating system like Linux and that likes to program in C at the lower level. In this case, the interesting part is that you can see in practice some operation. In this case, the programming language and the prerequisite is the C programming language. Also in this case, I provide a link to a paper number 6, and in this case, so the other activity can be performed at home or in Milan or in Turin in the laboratory. In this case, you need to perform this activity on our laboratory in Turin that, as I said, is at Politecnico di Torino, because you need to practically implement the software. Finally, there is the activity related to eQR codes. This activity, as I said, is an activity related to formal language and compilers, and in particular to my course of formal language and compilers. It derived from an idea that I had more or less 1 year and a half ago, 2 years ago, and the idea is that to place the program inside a QR code, because you know that there are a lot of situations. So you are in a mountain, you are in a boat, you are also in a restaurant in Milan, in an older restaurant, on which your cell phone has not connectivity. So in this case, you cannot scan the QR code, because typically the QR code contains a link that points your cell phone to a remote server. So with our technology, all the program can be built inside the QR code. And so, for instance, you are inside a boat, you have a problem on the motor, you can scan the QR code, the QR code can ask you some question and can guide you on solving the problem, or on the correct page of the manual where you have the definition of the problem and the solution. So for now we implement a decision tree, so the software of a decision tree, and we add in this case an article number 7, that was done with my thesis students that currently is doing the PhD with me, or better, it was done by 2 of my thesis, and near to this link I will also provide reference number 8, that is a reference to a GitHub where you can find the software of this implementation. So we start with this implementation that is for decision tree. We have a lot of idea of other possible implementation. Before speaking about that points, I want to describe how all the toolchains work. So the idea is that we start with a program described with an high-level language. From this program we obtain an intermediate code that can be seen like three-address code, but in this case the instruction has a higher level than three-address code. Because we have not the limitation of the CPU, and then this is translated into a binary file that is written the sequence of 0 and 1 inside the QR code. The problem is that why we need a different intermediate code for different application contexts, because unfortunately the QR code has a total size, a maximum size of 3 kilobytes. 3 kilobytes is not a too big size, so we have to do a big research on try to obtain an intermediate language that has a really good compression level. Then starting from our eQR code, so from our QR code that contains binary code, we reconstruct the intermediate code and we use a virtual machine to execute it. Okay, so the thesis is to start with a different application context, different than decision tree, and to build all this toolchain. Or if you want to start to other theses that are arrived to a given point and to finalize them. Regarding this part, the programming language is Python, but I don't exclude to use other programming language like JavaScript, in the sense that I'm working on this part from, or better on this other part, from QR code to virtual machine, to port this code inside JavaScript and to integrate it inside an application on the cell phone. Okay, as I said, and as you see, I have a lot of theses. I have also other theses, but I think is enough. I would like, if you are interesting or little bit interesting, that you can ask me, so we can have a call to have more details about this thesis. Remember that in my personal website https://scans.it/ss you have all the information about me, you have all my publications, you have other information about research activities. Regarding thesis, the information is quite old, so refer to this video, but you have the list of the last thesis I had. Okay, thank you very much for the attention and see you.